Welcome learners in the third session of the course MST 11. This is the first course of the master degree program MSc in Applied Statistics, and we have already discussed two sessions, and in the first two sessions we have discussed unit number 1 of the course MST 11. Today we will discuss unit number 2 of the same course MST 11. So today's session title is types of functions of single variable. In this session is actually jointly prepared by me, Dr. Rajesh, and Dr. Prabhat Kumar Sangal. Outline of the today's sessions are: first we will discuss definition of the functions. Actually we have already discussed definition of the functions in the second session, but we will just give overview of the definition of the functions. Then we will discuss types of functions, one function, on-to functions, and both one and on-to. And then if a graph of a function is given, and if we want to check whether this function is one or on-to, we can use the horizontal line test. And finally we will discuss the total, how we can find total number of functions, one functions, on-to functions, and both one and on-to. Now we just because we have already discussed this portion, definition of function, in the second session. Definition of function says that if we have two non-empty sets x and y, and then a rule which associate each element of x, this is important, each element of x, to a unique element of y. This is another important thing. Unique element of y is called a function from x to y. X is called domain of the function, y is called codomain of the function, and the subset of y of those elements of y such that for some x belongs into capital X, y is equal to f of x. Y is called the range of the function. Now if we try to visualize a function as a behave like a machine, suppose we have a function from set of integer z to z. Z here, z means denotes set of all integers. This is the set of all integers 0, 1, 2, 3 and so on, and -1, -2, -3 and so on. This is known as set of integers. We input are coming from the set of integer, and output are also in the set of integers. And this is the domain. And what function we have defined? This function just takes, if your input is x, just square of that number, x square plus 1. So if my input is 0, then my function will do square of 0 is 0, then plus 1, so 1, I will get output as 1. And if I give input 1, then 1 square 1 plus 1 2, so output will be 2. Similarly, if input is -1, then -1 square 1 plus 1 2, so same output that I got when I gave the input 1. So when you give input 2, then 2 square 4 plus 1 5 and so on. So these are the output sets. But in you know that in set theory we do not repeat the elements, so you can simply write these 2, instead of 2 times we can simply write 2 once, and similarly 2, instead of writing 5 2 times, we simply write 1 time. So this is known as the range of the set. The output, what is the range? The set constituted by the output of the functions. So these are the outputs of the functions, and these are, if when we write all the output in a set, then that set is known as range of the function. Now see, this range is nothing but the subset of the set of integers. Because all these 1, 2, 5, 10, they are sitting somewhere in this set of integers. So this is known as the codomain of the function. So with a function there are 3 terms related. One is domain. What is domain of the functions? That from where input are coming, that is the domain of the functions. And what is the range? Range is nothing but the set of all outputs. And what is the codomain? Codomain means it whatever function. Here we have defined this function from z to z. So that is the. Now we can in the previous example we have just talk about the term, the domain for the function, range of the functions. You can understand these things with the simple example. Suppose our x is the set of daughters and y is the set of mothers. Then if we consider the situation from A to D, now in these 4 diagrams, now in this A, I have 3 daughters D1, D2, D3, and I have mothers, 4 mothers M1, M2, M3, M4. The definition of function says that each daughter should have a mother. That was the first condition. If you go through the definition, each element of X should be associated. It means each element of X, here element of X are daughters. So each daughter should have a mother. This is the first condition. And second condition says that each daughter should have a unique mother. If you go through the definition of the function, then it says that unique element of Y. Means one daughter cannot be associated with more than one element of Y. So here for D1, that unique element is M1. For D2, that unique element is M2. For D3, that unique element is M3. Here M4 is a mother having no daughter. That is not a problem. So this is a function. This satisfies both the condition. All daughters have mothers and each daughter have unique mother. Now if we come to this B part, here this daughter D1 has 2 mothers, because this D1 is associated with the M1 and M2. So, but this is not according to the first condition of the function. According to the second condition of the function, each daughter should have a unique mother. But this D1 daughter does not have unique mother. So, this is not a function. Second condition violated in this B part. Now, we come to this C part. Here we have 3 daughters D1, D2, D3. But daughter D3 has no mother. But this is the violation of the first condition of the function. First condition says that each daughter should have a mother. So here D3 mother, daughter D3 have no mother, so it is not a function. So B part is not a function because second condition violated. This first C part is not a function because the first condition violated. All daughters should have a mother, but here D3 does not have mother. So now come to the fourth part. We have 3 daughters, all daughters have mothers, no problem. So first condition is okay of the function. Now second condition says that each daughter should have unique mother. For this D1, that unique mother is M1. For D2, that unique mother is M2. 2 or more daughters may have the same mother. That is not a problem. Problem is one daughter cannot have more than one mother. So here both conditions satisfy. This is also a function. So this A part is a function, D part is a function. B and C part are not functions. This is just in this part A. If we talk about the domain is nothing but the set of all daughters. And what is the codomain? Set of all mothers, M1, M2, M3, M4, the all mothers. And what is the range? Only those mothers having daughters, M1, M2, M3. In this part, because the B and C are not functions, so we cannot talk about their range and domain. Now this C, D part, here set of all daughters is domain. So here domain have D1, D2, 3 elements. Codomain, set of all mothers. But in range, only those mother having at least one daughters. This M1 mother have 2 daughters, so this will be part of the domain range. And this M2 mother also have 1 daughter, so this will also be the part of the range. So in range we have only 2 mothers, M1 and M2. Now we start from the today's session from the types of functions, and the first type is one-one functions, and another name of the one-one function is injective functions. This definition says that if we have 2 sets A and X and Y, then a rule, this is the notation to write the function f taking the inputs from X and outputs are constituted in or you can say the subset of Y, is said to be 1-1 or injective if distinct elements of X are associated with the distinct elements of Y under F. Or you can say if you take 2 elements X1 and X2 in X and they are different, X1 is not equal to X2, then their images should be different. Mathematically, we use the technical word image. F of X1 means image of X1. F of X2 means image of X2. So if X1 and X2 are different, then their images should be different. Or you can say that if images are same, then the input should be same. If you recall, if we try to compare this definition with the example of daughters and mothers, you can say that this definition says that a function is said to be 1-1 if different daughters have different mothers. For example, here, see here we have daughter x1, x2, two different daughters, but their mother are not different. So this is not one-one functions. One-one function condition says that different daughters have different mothers. So this is not one-one function. Now if we take this example, here x1, x2, x3, we have three different daughters, and you can see that their mothers are also different. Mother of x1 is y1, mother of x2 is y2, mother of x3 is y3. So we have different daughters, have different mothers, condition satisfied. So we can say that this function is 1, 1. Here y4 is a mother who does not have any daughter. That is not an issue with the 1, 1 function. Or 1, 1 function condition says that different daughters have different mothers. Only this condition satisfied. And all mothers should have daughters. That we will discuss in onto functions. In onto functions, the all mothers should have at least one daughter. So for 1, 1 functions, if a mother does not have any daughter, that doesn't matter. So this is a 1, 1 function. Onto functions. Now this onto functions, if we have two non-empty set x and y, then a function from x to y is said to be onto. Another name of onto function is surjective function. If each element of y has at least one pre-image in x, and if we write this in word statement like this, if you take small y, you know that small y means it is a member of capital Y. Capital Y is a set, and the member of the sets are denoted by small letters. Small y means some member of capital Y. So there exists at least one x, small x belongs into capital X, such that f of x is equal to y. If we try to compare this definition with the example of daughters and mothers, then you can say that daughters and mothers says that each mother should have or must have at least one daughter. In case of the 1, 1 function, what was the condition? Different daughters have different mothers. But in case of onto functions, we have the condition each mother should have at least one daughter. So if we take this example, here mother y1 have daughter x1, no problem. Mother y2 have daughter x2, no problem. Mother y3 has daughter x3, no problem. But this mother y4 does not have any daughter, so this cannot be onto function, because condition of onto function says that each mother should have at least one daughter. If a mother have more than one daughter, that is not a problem, but each mother should have at least one daughter. So this is not a onto functions. Now we take this example. In this example, we have two mothers. Y1 mother has two daughters, x1, x2, no problem. Two daughters can have the same mother, that is not an issue according to the definition of the function. Now this y2 mother have three daughters, again no problem. Three daughters may have same mother. Now we have only two mothers, and all the mothers have at least one daughter. First mother have two daughters, second mother have three daughters. So the condition of onto is satisfied here. Each mother have at least one daughter. So this is the situation of a onto function. Now if a function is both 1, 1 and onto, that is known as bijective function. Bijective function and injective function is used for 1, 1 function, and surjective for onto function, and bijective means both 1, 1 and onto. So you can say 1, 1 and onto, or you can say bijective functions. A function f from x to y is said to be 1, 1 and onto, or bijective, or another name for this bijective function is 1, 1 correspondence. If it is both f is 1, 1, it should be 1, 1 as well as onto. If you compare this definition with the example of daughters and mothers, then you can say that each mother has exactly one daughter. Or you can say no mother there is no mother who does not have any daughter. So if we take one example, in this example I have the set x 1, 2, 3, 4, and set y has 4 elements 2, 3, 4, 5, and I have defined this function like this. If x is the input, then this function is doing nothing but simply add 1 into the input. Whatever input I have, the output of this function will be just increase that input by 1. So if my input is 1, then 1 plus 1, 2. So output will be 2. Then if I take 2 as input, then 2 plus 1, 3 will be output. So you can see that different daughters have different mothers. Here I have four different daughters, and all the 4 different daughters have different mothers. So this is a 1-1 function. And what was the condition of the onto function? Condition of onto function was each mother should have at least one daughter. I have 4 mothers here, and each of these 4 mothers have at least one daughter. In fact, exactly one daughter each mother have. So both condition of 1-1 as well as onto are satisfied. So this is the example of a function which is both 1-1 and onto. Now if a graph of a function is given, and if you want to check whether this is the graph of a 1-1 function or onto functions, then to check that we use the horizontal line test. So horizontal line test for the function to check whether this given function is 1-1 or not, we use this test. This test says that each horizontal line either does not intersect the graph of the function at all, or if it intersects, it will intersect exactly at one point. In other words, there should be no horizontal line which intersect the graph of the function at 2 or more than 2 points. And this is the condition for the onto functions. If we want to check whether a given graph is the function of onto function or not, you can check that each horizontal line should intersect the graph at least at one point. Now, to explain this horizontal line test, let us consider these 4 examples. The first example, this R means set of real numbers. So these inputs are coming from the set of real numbers, and output are also set of real numbers. And this function is defined by f of x is equal to minus time x square. Means whatever input you have, first square that number and then put negative sign. So this is the first function. Second function, this R positive, R not positive means this is the set of positive real numbers. Here we will discuss, we will include only positive real numbers. R not means only all the real numbers other than 0. And this function, why we have put this condition? Because here we have defined 1 by x. If x is equal to 0, then 1 by 0 is not defined. That's why we have not taken 0 in the domain. So, and the third function is set of real number to real number defined by fx. Whatever input you have, the output is the same number. And this is the 4th functions. Now these are the graph of these 4 functions. Now we check these 4 functions one by one, whether it is 1-1 or onto. And you see that on y-axis we take the value of y. And if we take a value of y, means we suppose you are taking mothers on y-axis, and this is your x-axis, and on x-axis we are taking daughters. Then condition of 1-1 says that different daughters have different mothers. Now if I take, see if I take this, suppose this is mother on y-axis, this mother. If I draw a horizontal line, see this is the horizontal line. This horizontal line will intersect the graph at 2 points. One point is this and one point is this. And when I draw perpendicular on x-axis from this line, I will get 1, and from here I will get -1. So you see that, and suppose this point is your -2, 0 and -1. This is -1. So if I take -1 as mothers, then you see that I have 2 daughters, 1 as well as -1. So because this graph or this horizontal line intersect the graph at 2 points, it means the corresponding to this mother I have 2 daughters. So, and the condition of 1-1 function says that different daughters have different mothers. Means 2 daughters cannot have the same mother. So this function is not 1-1 function, because if I draw a horizontal line, its graph it intersects the graph at 2 points. But according to the condition of one function, each horizontal line should intersect the graph at exactly 1 point. So this is not one functions. Now what about the onto functions? Onto function says that each mother should have at least one daughter, and mothers are sitting on y-axis. If I draw a horizontal, suppose this is a mother, and if I draw a horizontal line from here, see this horizontal line does not intersect the graph at any point. It means this mother does not have any daughter. So this is not an onto function. If you can find a horizontal line which does not intersect the graph at all, it means it is not an onto function. This is not onto, and it is also not one function. Now come to the second function. Now this second function, if you draw any horizontal line, it will intersect the graph at exactly 1 point. Draw any horizontal line, it will intersect its graph at exactly 1 point. So it is one function. But if we talk about the onto function, the condition of onto function says that each horizontal line should intersect the graph at least at 1 point. So if I draw a horizontal line like this here, then it will not intersect the graph at all, because you see the graph, this definition of this function is 1 by x, and here x takes positive values. If x is taking positive values, then we suppose x takes value 2, so 1 by 2, 0.5. You will get never negative value. All the time you will get always positive value, because x is positive. X is cannot be negative. So if you will take on y-axis, I have negative numbers. So when I take any number on y-axis and I draw a horizontal line passing through that point, that will not intersect the graph at all. It means all the negative numbers on y-axis, because on y-axis I have my mothers are sitting, so it can take any mothers corresponding to a negative number that and draw a horizontal line. That horizontal line will not intersect the graph at all. So it means that mother does not have any daughter, so this function is not onto. Now come to this third part. This is a very nice function. This is actually linear function, and see this, draw any horizontal line. It will intersect the graph exactly at 1 point. So it is one function. Each horizontal line will intersect the graph at exactly 1 point. So it is one functions. Now what was the condition of onto functions? To become onto function, each horizontal line should intersect the graph at least at 1 point. And in this case, each horizontal line intersect the graph exactly at 1 point. It means each mother have exactly one daughter. So each mother has a daughter, at least one daughter, so it is a onto function. So this function, this graph is the graph of a function which is both one and onto. Now come to the fourth part. If I draw a horizontal line from here, so it will intersect the graph at exactly 1 point. No problem. But see here, if I draw a horizontal line like this, it will intersect the graph at 3 points. 1, then 2, and then 3. So it means this mother has 3 daughters. It means 3 different daughters have the same mother. But according to the condition of one function, different daughters should have different mothers. But here 3 different daughters have same mother. So this is not one functions. For the condition of one functions, each horizontal line should intersect the graph exactly at 1 point, or means at most 1 point. But if this is not one function, but what about the onto functions? Condition of onto function says that if I draw any horizontal line, it should intersect the graph at least at 1 point. So this condition is satisfied, because draw any horizontal line, this intersect at 1 point, this horizontal line intersect at 1 point, this horizontal line intersect at 3 points, and if you draw any horizontal line below this, again intersect at 1 point. So it means each horizontal line will intersect the graph at least at 1 point. So it means each mother have at least one daughter. So this is the graph of onto function. Now if some function is given, and if you want to check whether this function is 1, then we can check this by algebraically also. We have just discussed the horizontal line test. Means if graph is given, then we can check whether this function is 1 or not. But if we want without graph, if you want to just check whether the given function is 1 or not, what you can do, take 2 daughters. This x1 means we have taken 2 daughters, and what we have done, put f of x1 means mother of x1, mother of x2. Just put their mothers are equal and solve this. After simplifications, if I get x1 is equal to x2, means if 2 daughters have the same mother, then those daughters should be same. Then that function will be 1, 1. Otherwise, not. In this case, if I define a function fx is equal to 7x plus 5. Now I have to prove that this function is 1, 1. Just take 2 numbers, x1 and x2, because here domain and range both are R. So this x1 and x2 belongs into this R. So I have taken 2 elements x1 and x2 such that f of x1 is equal to f of x2. According to the definition of f function, this says that just replace x by x1. So 7x1 plus 5. 7x1 plus 5. F of what is the value of f of x2? Just replace x by x2. 7x2 plus 5. After that, cancelling this 5 both sides, I will get 7x1 is equal to 7x2. 7 cancel with 7. So x1 is equal to x2. Implies this thing f is 1, 1 function. And if I take another example where this function is not 1, 1. Because if I take x equal to 2 and x equal to 2 equal to minus 2, here x1 and x2 are not same, but value of x1 2 square 4 and value of minus 2 again 4, means 2 different daughters have same mother. So this is not 1, 1 functions. To check whether the function is onto, what we can do, we have to take a mother. So we have to consider from y from here. Then if y is in R, then y minus 5 is again a real number, and if you divide by 7, that will also be a real number. So this is a real number. But if I put f on this number, y minus 5 by 7, then function says that 7 times of this plus 5. 7 cancel with 7, y minus 5 plus 5, 5 minus 5 cancel out 5. So if I consider any y from y, I find a mother, I find a daughter. This if I consider started with a mother y, and I find that y minus 5 by 7 is his daughter, means for each mother I have a daughter. So this is an onto function. Then we can find out the total number of 1, 1 functions, onto functions, and this both functions. If I have set A has m elements, set B has n elements, then total number of functions from A to B will be n is to power m, and total number of 1, 1 function will be n to n minus 1 into n minus 2 and so on, n minus m plus 1. And total number of onto functions, this is the formula for the total number of onto functions. And if we take some examples to apply those formulas, if I have a set A has 5 elements, set B has 7 elements, then total number of functions from A to B will be 7 is to power 5 is equal to this. If I want to find out how many 1, 1 functions are there from A to B, formula was n minus 1, so n is 7, 7 minus 1, 7 minus 2 and so on up to here m is 5, so 5 minus 1, 4, go up to 7 minus 4. So this is the total number of 1, 1 functions. Then this is the formula for the total number of onto functions. Just replace that in that formula, and after simplification you get this 150 functions. And total number of 1, 1 functions, which is both 1, 1 and onto. If I have both set A and B have 5 elements, then my total number of 1, 1 and onto function will be factorial 5, means 120. So this is all about today's sessions. In today's session we have discussed definition of the functions, and after that we discussed types of functions, 1, 1 onto and both 1, 1 onto, and then we discussed horizontal line test, and at last we discussed total number of functions. If you want to count how many functions are possible from A to B, 1, 1 onto and both 1, 1 onto. Thank you, learners.
My name is Dr. Subha Jain, and I am a student of SOPBA IGNOU, रिसर्च स्कॉलर। जैन आर्किटेक्चर पे मैंने PhD की है। को हर टॉपिक